Alright. Your essential questions for today are, how do you use a linearization to approximate a function value? And I think for you to write your summary for this, you might have an easier time having an example. So as an example, say that you are told that it needs to be at x equals 3 and that you want to approximate f of 3.1 and explain your steps based on that example. And then your second essential question, in your words, if you are given y, how do you find dy? Okay. That'll be pretty simple. It'll come at the end. Your main goal today is working on linearizations and what they tell you about the function for AP writing. So you're going to find linearizations and approximate with them. And then you're going to find what we call differentials, and that goes back to that second essential question. The idea of linearization, we've already talked about linearization before. You've already written tangent lines. So what we're doing is using the idea that a tangent line behaves very similarly to your function near the point of tangency. So we're going to approximate the graph of whatever function we're dealing with, or the function itself, with its tangent line, as long as we're staying inside what we call a neighborhood, very close to the point that you made your tangent line with. So basically it's more tangent line practice, and then like we talked about last week, you can now talk about concavity and overestimates and underestimates. So first example, they give you a function, they give you a point, and they want a tangent line t to the graph at this given point. So if we start with our function, knowing for tangent lines you need slope and a point, so I'm going to rewrite f of x as 6x to the minus 2, so that then I can get f prime of x as negative 12x to the minus 3 without using quotient rule or anything. So negative 12 over x to the third. I need the slope at the point they're telling me, so I need f prime of 2. So f prime of 2 is negative 12 over 2 cubed, so 8. So negative 12 over 8, and I can reduce that down to negative 3 over 2. So this is my slope, and then my point is 2 comma 3 halves. So putting those together, I get my line. And again, as we've talked several times, point slope form is easiest. You make the fewest mistakes. So y minus 3 halves equals your slope, negative 3 halves, times the quantity x minus 2. That's my tangent line, and technically I would be done, except they told me to call my tangent line t. So basically they're wanting you to solve this for y. It's still going to be easiest to work with if you leave it in point slope form. So y would equal negative 3 halves, quantity x minus 2, plus 3 halves. And then you could just rename that t for tangent line equals negative 3 halves x minus 2 quantity plus 3 halves. I would leave it there. You are welcome to actually distribute and solve it all out. If you do, you would get negative 3 halves x plus 9 halves. But like we've talked, you're more likely to make a mistake. You don't get your credit for AP if you do make a mistake, so it'd be easiest to just leave it in the parentheses format. So that was something, you could have been asked to do since way back in chapter 2. This next one, they kind of change the directions on you a little bit. So they say that you need to find the linearization L of x. So you're going to rename it, instead of t, you're going to rename it L of x. And then they're telling you at x equals a. So if I go read the question, a is 1. So to answer part A of this question, I need the function f of x that they give me. I need the point a equals 1 that they're giving me. For the function, I'm going to rewrite it as f of x equals x plus x to the negative 1, so that f prime is easier to find. So f prime will be 1 minus 1x to the negative 2. So 1 minus 1 over x squared. And I'm interested when a is 1, so f prime of 1 is 1 minus 1 when I plug in, so 0. So this time I have a 0 slope. The point that I need, they actually didn't tell me. So I need the point whenever x is 1, I need to figure out what f of 1 is. So f of 1 would be 1 plus, going back to the formula for f, 1 plus 1 over 1, so 2. So my point is 1, 2. So I can get my line that it's y minus 2 equals my slope 0 times the quantity x minus 1. So that really just means that it would be the constant line, horizontal line, y equals 2. That my tangent line is the horizontal line, y equals 2. They do want me to rename it L of x, so L of x equals 2. And that answers part A of the question. That's my tangent line. Then for part B, if you go back up and reread, for part B they want to know how accurate your approximation is. And so they're asking you to compare L when you add 0.1 to the A value, so L of 1.1. And they want you to compare that to f of 1.1. So they're telling you to start with the a value, in this case of 1, and add 0.1 to it. So we want to find each of those and compare. Well, L of 1.1, since L of x was always 2, then L of 1.1 is 2. F of 1.1, going back to the function, would be x plus 1 over x. So 1.1 plus 1 over 1.1. If this is without a calculator, which it very well could be, this becomes 1 over 11 tenths, because 1.1 equals 1 and 1 tenth. So 1 over 11 tenths is 10 over 11, multiplying by the reciprocal. So f of 1.1 is 1.1, but I'm going to rewrite it as 11 tenths, plus 1 over that, so its reciprocal was 10 elevenths. And then you would get a common denominator. So you would come back and multiply this part by 11, and multiply this part by 10, top and bottom. So you would figure out that we have 121 plus 100 over 110. So 221 over 110. That's the same thing as 2 and 1 over 110. So I have a value for L of 1.1, and I have a value for F of 1.1, and they want me to compare how accurate they are. So if you ever have to find error, error would be in absolute values, the difference between F of 1.1 minus L of 1.1. We put it in absolute values because it really doesn't matter if you want to subtract L first or F first. It's just how far apart those are. And so if you go back up and compare 2 and 1 over 110, and then just 2, those would be 1 over 110 apart. So the error would be 1 over 110. What this tells us, if you look a little bit further, some AP conclusions that you might want to find. if you notice that L of 1.1 actually underestimates, because it was just at 2, it underestimates f of 1.1. So going back to what we talked about last week, if your tangent line is an underestimate, that should ring a bell that it's a concave up shape. So that could tell you that f is concave up at x equals 1.1, and actually in like a small neighborhood around, small region around 1.1. Connecting to the derivative, that could tell you that f prime of 1.1 is increasing, because concave up goes with increasing first derivatives. That could also tell you that f double prime of 1.1 is positive. So there are all kinds of different things that AP might want you to know by knowing L of 1.1 and comparing it to f of 1.1. A second thing would be if they just came out and asked for error. That's just wanting you to subtract and get that difference in absolute values. Sorry, I didn't mean to do that. Okay, next piece. We have a new function, and in this problem they want you to choose an x value to make a linearization from, but keeping in mind that they're asking for 8.5, they want you to approximate 8.5. So you need to choose something that is close to 8.5, and you need to choose something that's easy to work with in your function. So we're going to choose, since it's a cube root, we're going to choose our x to be 8, because we already know that the cube root of 8 is 2. We already know that value. So then for part B, they want you to find your linearization, L of x. So in order to do that, we want a tangent line at x equals 8. So I'm going to rewrite f of x as x to the 1/3 so that the derivative is easy. So f prime of x is 1/3 x to the negative 2/3. I'm going to go back to radical notation because that's usually easier to evaluate. So 1/3 times the cube root of x squared. So I want f prime of 8. So that's 1/3 times the cube root of 8, and then you can choose to square it inside or outside. I'm going to square it outside. So 1/3, cube root of 8 is 2, and then I need to square the 2. So 1/12. 1/12 is my slope. And then I need to actually get my point. Well, my point is going to be 8, comma, and I have to go back to the function f of 8. Well, f was the cube root, so I want the cube root of 8, which is 2. And again, that's why we picked 8, because it had an easy cube root. I have not seen an AP question that's asking you to pick where to write your tangent line, so I wouldn't worry too much about that. They usually come out and tell you where they want their tangent line. But again, we picked 8 because the cube root of 8 is easy. Alright, so we have our point and we have our slope. So our line is y minus 2 equals 1/12 times x minus 8. So that's our line, except they told us to call it L of x. So that's going to be easiest when you solve for y. So 1/12 quantity x minus 8 plus 2, and then just replacing the y with L of x. I'm going to do that on the next column. So L of x is equal to 1/12 the quantity x minus 8 plus 2. And that finishes up part B. And then part C, they want you to compute f of A. Well, f of A, our A value they gave us was 8.5. So they want f of 8.5. And the reason I had you leave that is because they also want L of 8.5. And it's going to be easiest to go into this format where you just have to subtract the 8. So we left the parentheses there. So as we do that, This part would be a calculator question because you're not expected to know the cube root of 8.5. So f of 8.5 is the cube root of 8.5, and you would go to your calculator for that. It's approximately, let me find it for you, 2.0408. Then you would be expected to do the L part without a calculator. So L of 8.5 is equal to 1/12 times 8.5 minus 8, so 0.5 plus 2. So you're taking 1/12 times 1/2, so 1/24 plus 2. So 2 and 1/24. And then at that point, I mean, you might have to figure out that decimal, but if they already gave you a calculator for the cube root, you could figure it out on your calculator as well. Excuse me. And that is approximately 2.0416. So when they're asking you to compare, let's just talk about how far off they are. So notice that they match as far as 2.04, and then they're off. So if they didn't actually come out and say error, as far as comparing, you wouldn't have to be super specific necessarily. We could say that like L of 8.5, think about whether it's an overestimate or an underestimate. The L has 0.0016 that would be left, and the F has 0.0008. So L of 8.5 overestimates F of 8.5 by approximately 0.001. If we wanted to elaborate for AP, that would, so meaning, since it's an overestimate, if you have that visual in your head from last week, meaning F is concave down at x equals 8.5. That's one type of comparison. AP will come out and specifically ask you what they want to compare. So maybe they want an overestimate, underestimate idea. Maybe they want to mention concavity. Maybe they want you to actually find error, so they would ask you for error. Okay, the next one, I chose to pick a couple of examples where they're giving you graphs, just because we're still struggling with whether it's the graph of f or the graph of f prime. Hold on one moment. Alright, so in this example, we have the graph of f, that we're looking at. And they want us to do a linear approximation to approximate f of 1.9 and f of 2.04. And if you notice on this graph, they tell you that for f, we have the point 2, 1. Well, the other thing we need to write the tangent line would be the slope. And if you notice, they drew out the tangent line for you at that point. So you just need to count out the slope of the line that they're giving you. And they'll always either give you a grid, or in this case, they gave us intercepts, so we can count out that slope. We went down by 2, and we went over to the right by 4. So the slope of that tangent line is -2 over 4, which is -1/2. So that technically means that f prime of 2 is equal to -1/2. They've shown you the tangent line, so you know exactly what the derivative value is right there. And again, that is our slope. So in terms of writing the line, you would have y minus 1 equals -1/2 times x minus 2. They didn't tell you to call it anything, so you don't technically have to, but in order to approximate, let's go ahead and solve it for y. So y equals -1/2 times the quantity x minus 2 plus 1. And since they didn't tell us what to call it, you could just make a note that f of x is approximately -1/2 x minus 2 plus 1. You could just say it's an approximation to f of x. So that's our tangent line, and they want us for part A to approximate f of 1.9. So that would be approximately negative a half. And then you need to take 1.9 minus 2, and then you need to add 1. So the 1.9 minus 2, we're down to negative 0.1. I'm going to do fractions if we're without a calculator. So negative 1/10 times negative a half plus 1. So then 1 over 20 plus 1. So 1 and 1/20th, if I go ahead and turn that into an improper fraction, 21 over 20. So f of 1.9 is approximately equal to 21 over 20. As far as the use of equal signs, you need the f is approximately equal to that, and up in this first line the f is approximately equal. For all the in-betweens, like from this line to this line, those are exactly equal, and this line to this line, those are exactly equal. But since we started with an approximation, even when we're done, the approximation wins out, so f of 1.9 is still approximately 21 over 20. It's not exactly equal to. And then we need to approximate 2.04. So f of 2.04 is approximately equal to negative a half. And when you take 2.04 and you take off 2, you would get 0.04. And then we need to add 1. If I'm doing it by hand, I'm going to switch over to fractions. So negative a half times 4 over 100 plus 1. And I could even do some cleanup there. Like the 4 over 2 would be 2. And so I'm really left with 2 over 100 negative, for the negative in front, negative 1 over 50 plus 1. Well, the 1 is really 50 over 50 minus 1 over 50, so 49 over 50. And again, that would be f of 2.04 would be approximately equal to that. But for all these in between, one line to the next, they are exactly equal. It's just that the approximation kind of wins out, so to speak. It's not the exact function value, it's the approximate function value. So that's how you do one if you're reading the graph of f. And if we look at the next one, they'll have us reading the graph of a derivative instead. They've switched up the letters on us to be g prime in this case, but so now I'm reading a derivative graph. So in this case, this point is not a point on my tangent line, it's that g prime of 3 equals 5. That is my slope. So then what do I do for the point? Well, if you go read the question, they tell you that g of 3 is 8. So g of 3 being 8, and that's in the original g function, your point is 3 comma 8. So I have my slope and I have my point, and I can then write my tangent line. Y minus 8 equals, my slope was 5, times the quantity x minus 3. Since I want to approximate function values, they didn't tell me what to call it, but I'm going to solve for y. 5 times the quantity x minus 3 plus 8. And I'm just going to say that in this case, not f of x, but g of x is approximately equal to 5 times the quantity x minus 3 plus 8. Okay, so I have my tangent line. Now I just need to use that to approximate g of 2.93. So that would be approximately equal to 5 times the quantity 2.93 minus 3, and then plus 8. And the reason those parentheses are nice rather than distributing, you're always plugging in something close to your point, so it's always going to be close to the negative 3, or close to whatever x value you plugged in. So when I clean that up, I would have 5 times negative 0.07 plus 8, so negative 0.35. So 8 minus 0.35 would be 7.65. And again, that would be g of 2.93 is approximately equal. In the in-between, you could use an exact equals, because that top line to that middle line are exactly equal. G of 3.1 is approximately equal to 5 times 3.1 minus 3 plus 8. So 5 times 0.1 plus 8. So you get 8.5 there. And again, from first line to second, those are exactly equal, but this last part, g of 3.1, is just approximately equal to 8.5. The approximation wins out, so to speak. So that's how you do one if you're looking at a derivative graph. A point on the derivative graph, coming back up here, is the slope of your original function. And then they're going to have to give you some information about an original function value so that you can get your point. That's really it as far as linear approximations. You've done all the basics before, just now you've got some graph reading to do, or they might phrase it a little bit differently. Another way of saying the derivative, they could say like dy dx format, something like that. Or you have a graph to read, you have something, maybe they're asking about overestimates, underestimates, concave up, concave down. They're just asking you more information, but you've done the basics. Then your second essential question asked you about finding dy, and that ties into what we call differentials. The only part you need about differentials, deal with these definitions, and specifically the definition you care about and you need to find is this differential dy. You need to know that dy is the same thing as f prime of x times dx. But they just go ahead and define for you what dx is. Dx is really your change in x, delta x. It's just an independent variable. We could do some other stuff with it, but we don't really need to. And then they give you this definition that dy is f prime of x times this dx part. A way that I think you'll have an easy time connecting is if we start off with, you guys already know that dy dx is really f prime of x. That's another way of writing the derivative. Well, now what you're really doing to come up and get this dy equals f prime times dx, what most kids find easiest is to just think about the fact if I multiply dx on both sides, then I can come up with that definition that dy is equal to f prime of x dx. That's how most kids think about it, and I asked you an essential question for you to put it in your own words, so that's one way of putting it in your own words. Another way is that you could have memorized what dy equals, and you could justify how these two are the same, that we know they're the same, by just plugging in the definition for dy. dy is really f prime of x dx. And then in that sense, the dx's cancel out, and you can reason out that it's the same thing as f prime, which we already know, so it's matching up to what you think. Again, most kids just think about finding dy dx and then multiplying both sides by dx. You need this for what we're going to do in future chapters, because you're going to work with something we call an integral, and it looks like a weird kind of stretched out s, and then there's going to be a function here, something that they give you, and then they're going to say dx. It's going to be in what we call differential form. So it doesn't make much sense to you now, but you at least need to know how to find that differential form. And you start off by finding the derivative, and then, like I said, you come back over here and you multiply both sides by dx. So let's practice a couple. So if this is my original function, I'm going to rewrite this. Y equals 2x cubed plus 1 to the fourth. My first step would be to find dy by dx. And this is a chain rule situation, so you have your outside function, which is something to the fourth. So that derivative would be 4 times that thing to the third. So 4 times 2x cubed plus 1 to the third. And then chain rule, multiply by the derivative of the inside. So 6x squared. So that's taking the derivative. Then this whole idea about a differential is coming back and saying, okay, I'm going to multiply by dx, so that cancels. I'm going to multiply by dx. So I get this differential dy is the equivalent of the 4 times the 6 would be 24x squared in front, and then 2x cubed plus 1 quantity cubed dx. Basically, it's a derivative with one extra algebra step. And you don't need to know what we're going to do with it at this point, you just need to know how to find it. This last part is not a chain rule, but I would think about the y as -1/2 and then x to the fourth, so that you don't really need to worry about doing quotient rule, because the 2 on bottom is just a constant. So then dy dx, so this is where that notation for derivative instead of y prime, the dy dx notation is more helpful, would be -4/2, so -2 x to the third plus 9x squared minus 2. And then just coming back over and multiplying by dx. You actually need a parentheses here because all those parts are added and subtracted. In our last example, all the terms were multiplied. So dy is equal to the quantity -2x cubed plus 9x squared minus 2, and then dx. The parentheses do matter, they are required. Again, you don't have to know what we're going to do with it, you just have to be able to take the derivative and multiply over the dx part. Okay. Next piece, as far as homework and just kind of notes and reminders. So as far as reminders, your 3.7 homework is due tomorrow, due Tuesday. We will quiz that on Tuesday in your groups if you've done everything. As far as the optional ones, I do remember. Number 5 was optional about the Norman window. But always there are notes on D2L that you can verify. That last slide of notes will tell you what's optional and what's required. So if you want to quiz in your group tomorrow, 3.7 homework has to be completely done. Take time today to address questions within your group about 3.7, and at that point make notes of whatever we need to go over tomorrow in class. I'm really hoping with rest today, I will do everything in my power to be there tomorrow and for the rest of the week for midterms. I can't do it today. 3.9 homework notes. So you can check back at this slide if you're ever wondering what's required and what's optional. So optional, number 2, 3, 5A just because it's in the notes, 2 and 3 just because they're kind of repeats of stuff you do later in the packet. Then 17 and 18, and then 19 and 20. But some notes on those. 17 and 18, those are graph interpretation. They're review questions, but they're on like how to go from F to F prime or how to go from F prime to F. And you guys are struggling with that. We want to do a whole day on reviewing that. We're actually going to do that tomorrow to get ready for your midterm and to get ready for your next test. So you really need to do those. They're just optional as far as your homework being completed. And then 19 and 20, 19 is on optimization, so like 3.7, and 20 is on related rates, so back last unit 2.6. Again, you really need to do those as you study for midterms because you struggled with related rates, and then optimization word problems are new. So yes, it's optional, But all of these things you really need for the midterm and your next test because it's cumulative. So I would do as much as you're able to do. Okay. As far as 3.9, we're getting ready for midterms. So yes, you're going to see approximation questions, but on Wednesday I know we've got PSAT where a lot of you are gone and just trying to use our time the most efficiently. The 3.9 quiz will be Monday, next Monday, a week from today, October 20th. Sorry, I miscounted. Next Monday, but that's October 19th. Okay? Because we will come back after your 3-day weekend and we'll go over your midterms from this week, and then you can take that quiz and ask any other questions as you get ready for your next test. So the test over 3B plus the fact that it's cumulative. So really everything we've done so far, but major focus on 3B is Tuesday, October 20th. Okay. I'm really sorry about your tests. They are done. They are curved. Later today I'll get them in PowerSchool for you, I promise. Tomorrow you will have time to reflect on those, see the answer key, ask questions. Thanks for your patience. It's just been a rough week with Gideon sick last week, and then now I'm sick. So I promise I will be back tomorrow. I will be there throughout the week to get you ready for midterms. Answer key to 3.9 will be on D2L like it always is. Thank you so much for your patience. I hope you have a good day.